Low Voltage Breakers Section 2. The Big Three Faults. The Three Dangers of Electricity. Welcome back to Circuit Protection Essentials. In our first video, we established that a circuit breaker's main job is safety. Now, let's get specific about what exactly it's protecting us from. Breakers' primary threats. There are three primary electrical faults that circuit breakers are designed to detect and interrupt. Understanding these is fundamental to understanding circuit protection. Overload, too much current. The first and most common fault is an overload. This happens when a circuit tries to draw more electrical current than its wires and connected devices are safely rated to handle over a period of time. The overload scenario. Think about plugging too many high-power appliances, say, a toaster, a microwave, and a coffee maker all into a single kitchen circuit. The combined current demand exceeds the circuit's capacity. The thermal trip mechanism. In an overload situation, the wires and the breaker itself start to heat up slowly. Most breakers utilize a thermal trip unit, often a bimetallic strip, which bends as it heats, eventually tripping the breaker and cutting power. This protects against gradual overheating and potential fires. Short circuit, sudden and violent. Next is the short circuit, a far more dramatic and dangerous event. This occurs when an unintended, low-resistance path is created between the live, hot, wire and the neutral wire, or between the live wire and the ground wire. The short circuit scenario. Imagine a damaged appliance cord where the internal live and neutral wires touch, or a nail piercing a wall and hitting a live wire, creating a direct connection to a metal stud. Instantaneous high current. The result is an almost instantaneous surge of massive current, potentially hundreds or even thousands of times the normal operating current, generating intense heat and destructive forces. The magnetic trip mechanism. To handle this sudden surge, breakers employ a magnetic trip unit. This is an electromagnet that, when subjected to the extreme current of a short circuit, instantly pulls a lever, tripping the breaker in milliseconds much faster than a thermal trip could react. Ground fault, the hidden danger. The third critical fault is the ground fault, also known as an earth leakage fault. This is particularly dangerous because it poses a direct threat to human life. How ground faults occur? A ground fault occurs when electricity escapes its intended path and finds an unintended route to the earth, often through a person who accidentally touches a live component. This current leaks away from the normal circuit. Up next, MCB Essentials. While standard breakers offer some protection against short circuits to ground, specialized devices are needed for effective human shock protection. We'll dive into those later. For now, understanding these three core faults prepares us for our next topic, MCB Essentials.